Hello. In today's class, you will be able to define density and relate density to volume and apply to solve in real world scenarios. Actually, density is a measure of the amount of mass in a certain volume. I repeat, density is a measure of the amount of mass in a certain volume. This physical property often used to identify and classify substances. It is usually expressed in grams per cubic centimeters or g per centimeter cube. The density of an object is calculated by dividing mass per volume. Mass per volume. You know, before going to the important point, that is the objects with density greater than 1 gram per cubic centimeters will sink in water. The objects with density less than 1 gram per cubic centimeter will float in water. What does it mean? You take a simple pin, a safety pin, or maybe the pin which we use to attach the papers. You put it on the surface of water, for sure that will sink. Again, you think of it. You take a small pin or maybe a nail and try to float it on the surface of water. No way, it sinks. But a ship which is made of iron, much heavier than a pin or a nail, but still why it is floating on water? The answer is so simple because it depends upon density. Because when the ship is made, the volume of the ship is large as compared to its mass. So when you take mass, volume into the consideration, then you can compute the density. So density equals to it is mass per volume. Mass per volume. This is the condition. Okay. So if the density is if it is greater than 1 gram per cubic centimeter, then it will sink. Whereas if it is less than 1 gram per cubic centimeter, then that floats on water. Right? So please remember, if it is less density, it floats. If it is more density, it sinks. Okay. Now let's go to the PowerPoint for the day. Okay, it's here. So density based on volume and area. Standard is geometry m dot g dot mg dot AO2. You'll be applying the concepts of density based on area and volume in modeling situations. That is persons per square mile and so on. Vocabulary 2D geometric shapes, 3D geometric shapes, I believe you have an idea. Next, density, mass, volume, area, and population. These we will be using in this standard. Now, what is density means? It is the crowdedness of space. Amount of matter as people crowded in space are playing. Look at this one. If you take solids, in science you might study at this point that solids are more denser than liquids, and liquids are more denser than gases. You know that in solids the distance between the molecules are very less, therefore they are denser, right? When it comes to real world scenarios, look at this train. It's a metro, and in this compartment, there are some people. You see that there are not many. That's fine. But you look at this picture. Oh my God! Look at the number of people per compartment. So it is more denser, right? Okay, so I would say that it is the crowdedness of space when it comes to people. Now, types of density. There are two types of density. One is material density, and the other one is population density. If you take material density, here D equals to M per V. Therefore, here it is mass per volume when we talk about material density. When it comes to population, D equals to N or A. N stands for, oh, my bad. So here, let me take my pen again. So N stands for, that is, number of people or maybe the population over area. Okay? The same thing, M stands for, here it is mentioned that M stands for mass and V for volume. And next, here, population, N stands for the population, or I can say that the number of people, and A stands for area. Okay, let's take an example. What is the density? What is the density of CO, carbon monoxide gas? If 0.196 grams occupies a volume, you know, every time please write the formula volume. What is mass means it is 0.196 grams. What is volume means you see that volume is given as 1000 ml. Therefore, it is 100 ml. So 100 milliliters. I need not take my calculator because when you divide a value by tens or hundred based on number of zeros, the decimal point moves. I see that there are two zeros in 100, right? So when you divide, the decimal should go to left side by two places. Therefore, 0.00, okay, 196. 196. We use the same units, that is grams per milliliter. So that is the density of carbon monoxide. It's a very simple example. So let me give one more example. A block of wood, 3 centimeters on each side, has a mass of 27 grams. Okay. So here, what is the density of the block? So don't forget, every time you write the formula, density equals to mass per volume. So what is the mass means? You see that it is 27 grams. Therefore, it is 27 grams. Fine. And next, denominator, volume. So shall I take 3 centimeters here? The answer is no. Because here the question is mass per volume means, please check whatever the number is given, is this representing the volume or not? Is this representing the volume or not? The answer is no. Because if you take a block of wood, each side is 3 centimeters means which means length is 3 centimeters, width is 3 centimeters, and height is 3 centimeters. I'm sure you know how to compute the volume. volume equals to, if it is a cube, so it is side times side times side. Then it is 3 times 3 times 3. 3 times 3, that is 9. 9 times 3, that is 27. So 27 cubic centimeters. Therefore, it is. So don't be in a hurry and don't write that 3 centimeters as volume. 3 centimeters is representing one side of the block, not the volume. So
Good afternoon.
I computed this one separately what the volume is. Therefore, 27 divided by 27. After the cancellation, I get 1 here. So it is 1 gram per centimeter cube. This one represents the density of the block. Okay? Okay. So let's take let's go back to the PowerPoint. Okay. One more question. Silver has a density of 10.5 grams per cubic centimeter, and gold has a density of 19.3 grams per centimeter cube, which would have the greater mass, 9 cubic centimeters of silver or 5 cubic centimeters of gold. You know, let me divide the page into two parts, silver and gold. So here it's given that silver has a density of 10.5 grams per centimeter cube, which means 1 centimeter cube of silver, the weight is 10.5 grams. Suppose if you are taking 9 cubic centimeters of silver, what will be its weight? What will be its weight? So 9 cubic centimeters. So what will be the weight? I'll give a simple example. If you take the cost of one pen, that is say $2, and what is the cost of maybe 9 pens? It is a simple logic that immediately the thought comes to your mind that 1 pen is $2, 9 pens, how much means immediately you say that it is $18. I know that if anything is connected to money, it's easy to compute, right? So here, what's the answer means it is 18. How did you get means 9 times 2, that is $18. Exactly in the same way, here I see that 1 cubic centimeter is 10.5 grams, 9 cubic centimeter, what will be the mass means obviously 9 times 10.5 we have to multiply, just as I mentioned in the example, right? So let me compute 9 times 5, that gives me 45, 94.5. This one is these many grams, 94.5. If you want, you can make use of calculator and you can check it. When it comes to gold, it's given that the density of gold is 19.3 grams per cubic centimeter or centimeter cube, which means 1 centimeter cube of gold weighs 19.3 grams. Then, if you take 5 cubic centimeters of gold, what will be the weight? I hope you remember that in my previous example here, 1 pen is costing $2. What is the cost of 9 pence? Means you know that what's the answer is. In the same way, 1 cubic centimeter is 19.3 and 5 cubic centimeters means what is the value? Means obviously we'll be multiplying 5 times 19.3. Let me compute. 96.5 grams. If you want to make use of calculator, and you can check it. So I see that 94.5 grams is smaller than 96.5, right? Therefore, what does it mean here? What does it mean here? So 9 cubic centimeters of silver weighs less than 5 cubic centimeters of gold. That means gold is heavy. I mean, it does not mean that heavier here. When you check the density, please look at the density that the gold density is higher. Therefore, even if you take 5 cubic centimeters, still it is weighing heavier than silver. Okay. Now, questions on this. Well, still, if you have any questions, please send an email. Let me jump back to my this one. Right. Now, here, related to population, Schutzwille is an island of 5,000 square miles off the coast of Djibouti. There are currently 250,000 inhabitants of the island last year. There were 12,000 new children born, all cute and very smart, and 10,000 people were recorded as deceased. Okay. So, the question is what is the current population density and what do you expect will happen to the density as time goes on? First of all, you know that when we compute the density of population, we take that number of people over area. Okay, so let me take that. Please don't forget here. N stands for number of people. Number of people. Okay, A stands for area. Now I'm going to compute two scenarios. One is what is the current population, and next when the changes occurred, like see that 12,000 newborn babies and 10,000 people are passed away. So what is here the condition means? Let me take a different color pen. Okay, give me a sec. Okay, so number of people means here in the beginning there were. Please see that 200. Oh, there are currently 250,000. Okay, mostly. Okay, so let me take that. Let's say that current population is 250,000, and next area you see that 5,000 square miles. Okay, so let me take 5,000 square miles. So let's cancel these zeros. Second zero, third zero, third zero. Therefore, 250 over 5. So it is 50. These all are people, right? So for 50 people, and remember these are the denominator is square miles. Okay, therefore this is square mile. This is the density. Let's say that the population, there is a change in population. Okay, so after that the change has taken place, let me compute. That is, in the beginning, 250,000 and 12,000 newborn babies. So, number of people are added to this population, which is 12,000. And next, my bad, here 1 0 extra I copied, so please ignore that. And next, 10,000 people passed away or died. So, 12,000 are born and 10,000 passed away means technically 2,000. The number is increased by 2,000. Therefore, it is 252,000. Now, what is the density means? You know, density equals to number of people or area. Number of people is 252,000 or area is 5,000 square miles. 5,000 square miles. If you look around, the same thing is happening across the world. You see that the more number of births are taking place and the deaths are going down. As this is what called as population explosion. Anyhow, let me compute this one. 252,000 over 5,000. I'm striking 3 zeros in the numerator and 3 zeros in the denominator. Therefore, I am left with 252 divided by 5. The number is 50.4. 50.4 people per square mile. Square mile. Now, what is it indicating? What is it indicating? Here, please see that earlier 50 people per square mile, now it is increased to 50.4. Suppose if it goes on and on and on, what happens is then it becomes 51, 52, 53, 54, and it goes on. Let's say that some 70 people per square mile. Just I'm taking some numbers. So, what is happening means number of people are increasing, but the land is not increasing. The land is not increasing, right? Just imagine a situation in our location itself. The number of births are more, but the land remains the same. Then we call that the density of population is increasing. Okay. Now let me jump to my whiteboard. Any questions on this population density? My apologies, just quickly I jumped. Any questions on this? Well, let me jump to my whiteboard now. I'll copy some questions from the worksheet. Now, here, first one is an example. You see that what is the density of a billiard ball? What is the density of a billiard ball that has a volume? Okay. So please notice that the volume is copied, the information is copied. Volume of 100 cubic centimeters and mass of 250 grams. So I see that mass is 250 grams. Now, those numbers are plugged in this formula. You see that mass, the numerator is 250 and this is 100. Then 0 and 0 cancel. 25 over 10 means 2.5 grams per centimeter cube. How simple is this one? Very, very simple. Let's take the next question and do it. Here, let me write the formula, which is density equals to mass per volume. Mass per volume. And next, let me copy the details. What is the mass? A loaf of bread has a volume volume of 2270 centimeter cube. Therefore, let me copy that volume is 2270 cubic centimeters. And mass is 454 grams. 454 grams. Well, now density equals to, I know that it is mass per volume. Now, let me plug in these numbers. Mass is 454 grams over volume is 2270 cubic centimeters. Now, I'm taking my calculator. Here I'm computing that 454 divided by 2270. That's giving me 0.2 grams per centimeter cube. Okay, don't forget, I have given an example that in the beginning of this session, I told you that if the density is less than 1 gram per centimeter cube, okay, then if it is less than 1 gram per centimeter cube, what happens is it floats. If you want to take a piece of bread slice and just put it on the surface of water, initially it floats. After a while it absorbs the water, then it sinks. I repeat, initially it floats, later on it sinks. Why means the reason is it is less than 1 gram per cubic centimeter. That's the density of a bread slice. But later on it absorbs the liquid, then it sinks. Okay, so let me take one more question really quick. Well, really quick, few examples. The first one is a block of wood has a density of 0.6 grams per cubic centimeter and volume. First of all, I prefer to write the information. So I see that the density is given. So density equals to 0.6 grams per cubic centimeter and volume of 1.2 cubic centimeter. What is the mass? What is the mass? This is the question. Actually, in my childhood, I learned one good technique. The technique is you draw a triangle. You draw a triangle. I call this one as magic triangle because without any difficulty, this gives you easy to compute. So let me draw the triangle first, then write English letter T inside this one. English letter T. It's easy to remember. Okay. Now, we know that the rule or condition for finding density equals to mass per volume. You have to remember this one. It is mass per volume. Now, please write the same thing here. Density equals to, due to lack of space, I am writing only den, equals to mass per volume. So let me write that mass in the numerator and volume in the denominator. Just I am writing VOL, that represents volume. Okay. Now, just assume that you want to find density. Anyhow, you know the formula for finding density is mass per volume, which you can see there. In case, if you are asked to find the volume, please either you close it or strike it. It is mass per density How wonderful is this one? If you want to find volume, just you strike it or just close it with your thumb, then you see the formula, mass per density. So that is my second rule, which is if I want volume, which is mass per density, mass per density. One more condition, you know how to find density, because already I told you to memorize this mass per volume. You know how to find volume, just now we derived. In case if you want mass, what to do? As I mentioned before, you may close with your thumb. But here density and volume, these two are side by side. They occur side by side. Therefore, it is a density times volume. I repeat, if you want to find what is mass means, you may hide it with your thumb. Then you see that the density and volume, they occur side by side. Therefore, you have to multiply them. Don't take them as a fraction. Therefore, what is the condition for finding mass means? That is density times volume. Now back to the question. The question is find the mass. You see that find the mass. Therefore, here mass equals to density times volume. Now just plug in these numbers. Density is 0.6 times. What is volume means? It is 1.2. You may take the calculator and multiply. You'll end up with 0.72. So mass is 0.72 means, look at the units carefully. I see that, my apologies, this one is masked. So 0.7 grams per cubic centimeter. We are computing mass. Therefore, this one must be in grams. Now, let's focus on the next question. A 800 grams boulder has a density. So 800 grams means here mass is given as 800 grams. A density of 8 grams per centimeter cube. So density is 8 grams per centimeter cube. What is the volume? So the question is, what is the volume? So volume means I can use this condition or this rule, right? So volume equals to mass per density. Now just plug in the values. What is mass means? I see that it is 800 grams, and volume I see that 8 grams. My apologies. Density I see that 8 grams per cubic centimeter. So 800 divided by 8 means it's simple. You get that 100. Anyhow, volume is 100 means, don't forget, you have to express the units. Therefore, here 100, what are the units means? You can see that that is cubic centimeters. Now, questions on this? Really quick. Any questions? Well, last question for today's session is this one. In fact, we use density concept in science also, in physics and chemistry. Here, I'm going to teach some chemistry related questions. Use the data below to calculate the density of each unknown substance. Okay, right. I see that mass is given as 4,725 grams. Volume is given as 350 cubic centimeters. the formula is used, and D is 13.5. So when it is 13.5, the substance is mercury. Okay. So I'll do one thing, I'll do the second one first, then I'll come back to first one. Mass is given as 148 grams and volume is 40 cubic centimeters. So let me write that density is mass per volume. Mass per volume. What is mass means 148 grams. 148 grams. And volume is 40 cubic centimeters. So let me take my calculator. 148 divided by 40. I see that 3.7. So density is 3.7 grams per centimeter cube. So I have to see where is 3.7. Okay, I found the answer here. So it's 3.7. Therefore, what is the substance means? You can say that it is based on the information provided, it is aluminum. Now let's look at this question. Mass is 171 grams. Volume is 15. Therefore, the density is mass per volume 171 over 15. Let me take my calculator. 171 divided by 15, 11.4. So density is given as 11.4. You may wonder why the units are not mentioned, means already it's mentioned that grams per centimeter cube. So where is 11.4 means I see that 11.4 is here. Therefore, what is the substance means? You can say that it is lead. Okay. That's it from me for today's session.